WarsawJS.
Welcome, mates. Probably some of you may remember me from the last year when I gave a lightning talk about some dates and leap year and so on. And in the September, probably a talk about temporal library. And today, I hope some of you are awake or at least alive. Are you? Okay, you've probably noticed that we have summertime, vacation, holidays, and so on and so on. And this time is great for taking plenty of photos and from your journeys, trips, and so on. And I want to talk about some technique of resizing photos, which may even save your life. Okay, plenty of images taken this time of holidays and so on. And many of these images, especially when displayed on mobile devices with responsive web design use and so on, are tortured in various ways. They are scaled, cropped, resized, and so on. And these procedures can lead to sometimes to distortion or even dropping the important details. For example, try to imagine what would happen if you have such a beautiful photo with your mother-in-law and you crop it out from the photo on her device. Can you even imagine it? I can't. Okay, and the idea is that some areas in the images are more important than the others. For example, at this photo we can see some tower, some castle, something like that, and some person. Maybe your father-in-law, remember about it. And these details definitely have to be preserved while manipulating that photo. And the other areas, the sky, the grass, and so on, can be thrown out. Okay, have you ever heard about the seam curving? I see. Okay, this is a technique of manipulating, especially resizing images, which is content aware. And this is the clue. The idea means that you try to keep more important details, pixels unchanged. It's said that these pixels have more energy than others. And the less important can be thrown out, completely removed. They are unimportant completely. How to do that? First, we calculate the energy, kind of importance, we may say, of every pixel, of each pixel in the image. Here is the example taken from the Wikipedia, of course, where the gradient magnitude was used. Every pixel, for every pixel was calculated the difference between their neighbors of the value. It may be done only horizontally, only vertically, in both directions. All the ways are possible. And some other ways are, of course, possible. These energies for each pixels can be calculated, or you can just select the areas which are of special importance. Okay, and then using the, for example, graph algorithms like Dijkstra's algorithm or dynamic programming, greedy algorithms or graph cuts, we find in the image paths called seams here of least importance. Here we have the example of seams starting from the top to the bottom. They are calculated vertically, but of course horizontal seams can be calculated, end of time. And when we find these seams, we can remove them because they are not important at all. Only the area not included in the seams, the tower here and the person, are left out in the picture. Okay, sorry. Oh, okay. And here's the comparison between simple scaling, where every pixel is treated the same way. Every pixel is resized like the same way. And here we can have the example of seam curving, where the important pixels are preserved, not distorted, and the unimportant pixels are completely removed. And your life is saved that way, because your mother-in-law will not be angry with you. Okay, this is of course only in the introduction, and you can read more about the technique with the links provided. Thank you for your attention. Have a nice evening.
Okay, well, since we're all comfortable and seated, for me that was very valuable information. I'm desperately searching for a free tool that I can use to scale. Image Magic. Okay, I'm gonna hope I can remember that. I'm so bad. It's just very, very bad. Does anyone have any questions about this presentation for Pan Tadeusz? Is anyone a graphic designer? Oh, there you are. Okay.
Yeah, I'm perfect presentation.
Thank you.
Please. Yeah, I'm interested to know how you calculate values or importance each pixels. I mean, it's special algorithm, or you check I don't know, hex of pixels around, or how?
The energies of each pixel, you mean?
Yeah.
Do you know Hyperskill portal? Former JetBrains Academy?
No.
It's some kind of educational portal with many topics devoted to programming and various projects to do and so on. And this is the link to the project with detailed explanation how to calculate the values for each pixel, their importance. As I've mentioned, one of the ways is the gradient, and we can separate each pixels to their values of RGB, and only selected or all of the values take the difference between their neighbors. And then just square difference, square root of squared difference, yes?
Yeah, I see. So you found some like unique or some specific object, yes, in all pictures.
Okay.
Oh, okay.
And this is this technique of gradient descent is used when you try to automatically calculate the differences. But of course, you can select the images, the areas of most importance by hand. Does it answer your question? Okay.
Thank you.
Yeah. So actually, I was using this technique. No, it's no. I'm just referring to the time when I was actually a designer, graphic designer. So I was using this. I used this technique in the Photoshop, content-aware scale and stuff like that. And a couple of years ago, I was quite surprised that the CSS, you know, magicians, like the kingdom of standards, they decided to enter the blending modes, exactly the same that we have in Photoshop. So I'm curious if maybe you know anything about some plans of the consortium of CSS. I don't remember the name, to introduce these ways of scaling into the CSS to be native.
I'm so sorry, but I don't have such knowledge. By the way, the other name of this technique is liquid rescaling. And as such, you can find it probably in Photoshop. And what else? At Wikipedia site, you can find interactive examples how the percent of distortion, how the percent of width of the target image influences the distortion percentage rate of two images. One is the tower and person, probably, as I remember, and the second one is the creation of Adam by God. And the second example is especially interesting because it shows that faces are much more preserved than other parts of bodies, for example, because they are of more importance.
Thank you very much, sir.
Thank you once more. And
one more big hand for Tadeusz.